Good morning, everyone. I am Pedro Ticiani, an undergraduate from the Astronomy department. My advisor is Alex Carciofi, and my project is spectroscopic contextualization of a sample of B stars observed by TESS. So let's contextuate briefly. B stars are mainly B-type stars, non-supergiants, with a high rotational velocity that has or already had a circumstellar disk ejected by the star itself. The TESS satellite is a space satellite with a mission to observe with high cadence the photometry of more than 1,000 stars in order to search for exoplanets. However, many stars in the list are B stars. So the objectives and methodology are listed as follows. Make an extensive search in the literature of spectroscopic data of B stars observed by the TESS satellite. Make an extraction from the spectra of three important line profiles, H-alpha, H-beta, and an iron line, normalized and in the velocity space. The identification of all B stars with many excellent spectra, with high signal-to-noise ratio, with spectroscopic observations near the test date, which was targeted. And then last but not least, the identification of forming events in these best stars, disk building, disk dissipation, isolated events, and stationary disk, so we can invest efforts in studying a reduced nicest sample. So, just to show a preview on the results, this is the Precious B star QR view. So in the first panel, we can see combined spectra centered on H-alpha normalized on the continuum in the velocity space. And in the second panel, we can see values of equivalent width of each profile versus time. So here we can see that a decade ago, the star passed through a cycle of isolated event with the disk rising and then dissipating quickly, and then the star passed some years without any disk, and then went through a second cycle with the disk building, and then a longer dissipation than the first one. And here in these vertical lines, we can see the date at which TESS targeted the star. So here, the star was without disk, with absorption in H-alpha. This is assumed the first isolated event present in the previous figure, so you can see clearly what is going on, with the disk rising and then dissipating, and the profile changing over time. Here we can see the second isolated event with a longer dissipation, and here we can see the zoom in the epoch TESS observed the star present in the figure 3. So here we can clearly see absorption in the H-alpha profile, so if we were to see the light curve from the star at this epoch, we wouldn't see any sudden rise in brightness due to the circumstellar disk. For the conclusions and perspectives, spectroscopy is not only necessary for the verification of the existence of a disk via H-alpha emission, but is capable of revealing dynamics occurring in a system in a wide range of timescale. The discovery of special B objects provides an effort in researching better the phenomenon through numerous methods. So being targets from the TESS satellite, one of these possibilities is the photometric variability study, which can provide many information about the star or system. Thank you.